Hello guys, in this video we are given a parabolic or quadratic function question which reads: the sketch below shows the graphs of f of x is equal to a open bracket x minus 2 squared plus q and g of x is equal to x minus 6. The graph of f cuts x-axis at a is equal to minus 2 and 0 and b, and graphs f of g intersects at b and d. The coordinates of e is 4k. And that's our graph of a parabola and a linear function. So this is a combination of a parabolic function and a linear function. A linear function is this straight line graph, which is in the form g of x is equal to mx plus c, but it is given already. Okay, the f is missing the value of a and q that we need to determine. All right, let us go to 4.1. Write down length of AB. To determine the length of AB, we need to find the coordinate of point B. So we can see that the point B is where our graph of f and g passes through, but we don't have the full equation of f. So we're going to use the equation of g to guide us to find the x coordinate of b, because the y we already know that it is on the x-axis, so y coordinate is 0. So meaning we're going to let y is equal to 0 for equation g. So that is going to be g of x is equal to x minus 6. So we let y is equal to 0. Our y is g of x, so that is going to be 0, x minus 6. By solving for x, this will give us x is equal to 6. So the coordinates of b, it's 6 and 0. So now we want to calculate the length of AB. We can use the distance formula, or which says square root x2 minus x1 squared plus y2 minus y1 squared. But in this case, both of them, they are lying in the same axis, so there's no need for using that one. We just subtract x coordinates. So that is going to be 6 minus 2, which is equal to 8 units. 4.2, determine the coordinates of D, the turning point of F. From our equation F, this minus 2, we know that is going to help us to find the x coordinate of the turning point. So turning point, since it is D, that is going to be D is equal to 2. If it's negative, it is going to be positive. So it's 2 and Q, but we don't know Q. We are going to use the same equation of g, because this point D is where also the g passes through. So we can substitute with x is equal to 2 to find the y. So we can say y is equal to, on our value of x, it's a 2 minus 6. That is going to give us minus 4. So that means the coordinates of D will be 2 and minus 4. 4.3. Show that the equation of f can be written as f of x is equal to x squared minus 4 minus x minus 3. Okay, so in this case, we can do it in two ways. The first method, we can take it further from here. We are given f of x is equal to a open bracket x minus 2 squared. Then value of q, now we know it is the y coordinate of t, which is minus 4. Then we are only shorting the value of a. So we can use one of the coordinates in the graph. We haven't used any x coordinate here, so we can use one of the x coordinates. I'm going to use minus 2 and 0 to substitute in our equation, then we get our a. So our y is 0 is equal to a open bracket minus 2 minus 2, then squared, and minus 4. Then I'm going to take minus 4 other side to become positive. Minus 2 minus 2 gives us minus 4 squared, which is equal to 16, then times a. Then we divide by 16 both sides. That is going to be 4 over 16, which is 1 over 4. So our a is 1/4. Then we come back and substitute it on that equation. So f of x will be equal to 1/4 x minus 2 squared, then minus 4. Then we expand those brackets. I'm going to do direct expansion. We square the first term, that is going to be x squared, x times minus 2, which is minus 2x, then times 2. That will give us minus 4x. Then minus 2 squared, it's a plus 4, then minus 4. Then we distribute 1/4 inside the bracket. It is going to be 1/4 x squared minus 1/4 times minus 4, we're going to get minus 1. Then 1/4 times the 4, we get plus 1, then minus 4. Then like terms, 1 minus 4, we get minus 3. This is our f of x. That's the first way of doing it. Let us see the other method. Now we have calculated the coordinates of b and we have coordinate of a. So we're going to use that coordinate method. So we need to write our parabola in a factorized general notation. So that is going to be f of x is equal to a open bracket x minus x1 x minus x2. So our f of x will be equal to a open bracket x1 and x2 are the roots. First root is minus 2, then the other one is 6. So our f of x is equal to a open bracket x minus, our x1 is minus 2, so that's going to be x minus minus 2, then x minus x2, which is the coordinate of b, which is 6. Then this is going to be f of x is equal to a open bracket x plus 2 x minus 6. Then we can use our turning point, the coordinates of d, to determine the value of a. So that is going to be minus 4 is equal to a open bracket 2 plus 2, then 2 minus 6. Then minus 4 is equal to a open bracket 2 plus 2 gives us 4. Then 2 minus 6, which is minus 4 times minus 4 times 4, we're going to get minus 16. Then we divide by minus 16 both sides. That will give us a 1 over 4. Then we come back at this stage and substitute with a is equal to 1 over 4. So f of x is equal to 1 over 4 x plus 2 x minus 6. Then from there we do 1 quarter open bracket x times x, we get x squared, then x times minus 6, which is minus 6x, plus 2 times x, which is 2x, then 2 times minus 6, we get minus 12. Then this is going to be 1 over 4 open bracket x squared minus 6 plus 2, we get minus 4x, then minus 12. Then we distribute the 1 quarter inside. That is going to be 1 quarter x squared minus 1 quarter times minus 4, we get minus 1. So that is going to be minus x. 1 quarter times minus 12, that is going to be minus 3. So our f of x is equal to 1 quarter x squared minus x minus 3. 1 quarter x squared is equivalent to x squared over 4. It's just the same thing, then minus x minus 3. Next question, 4.4. Determine the value of k if E is the reflection of C with respect to the axis of symmetry of F. Before we find the value of k, we need to find the coordinate of C. Coordinate of C is the y-intercept of graph of F. So we found that our F, this constant value of F, gives us the y-intercept, which is minus 3. So coordinates of C, it's 0 and minus 3. Since this E is the reflection of C, it means the these two coordinates are going to maintain the same y value, which is the y coordinate. So meaning the value of k here is going to remain minus 3. So k is equal to minus 3. 4.5. Determine the equation of tangent to the curve at E if tangent is parallel to G. Tangent is parallel to G. We need to know the properties of parallel lines is that they have the same gradient. So meaning y is equal to mx plus c. Our m is the same. Gradient of this G, it's a 1 here. So this is going to be y is equal to x plus c. Then it is passing through point E. Point E, which is 4 and minus 3, because we have calculated k. Then we substitute this value to find the coordinate, the value of c. So that is going to be minus 3 is equal to 4 plus c. Then our c is going to be minus 3 minus 4, that will give us minus 7. Therefore, y is equal to x minus 7. That's our equation of the tangent to curve at point E. 4.6. For which values of x will f of x minus g of x is less than 0. So in this case, we just need to rearrange our equation. Here we can take the g of x that side to make it positive. So that is going to be f of x is less than g of x. So we are trying to find the value of x by which the graph of f is less than g of x. Our f is this parabola, g is a linear. So we can see at this point or this region, our f is less than g. So we are from this x coordinate of d up to the x coordinate of b. So which means on our solution we can write that 2 is less than x, which is less than 6. You start with a smaller value of x going to the bigger one. Or you can represent it using the bracket notation, which is x is an element of, we are from 2 up to positive 6.